हेलो दोस्तों, कैसे हो? मेरे इस YouTube चैनल में आपका स्वागत है। तो चलिए शुरू करते हैं।
Now the next topic which I am going to take here is considerations. What do you mean by considerations? Consideration means what are the factors, points, elements that you will think of when you are designing a part. Procedure देखा कि कोई भी part कैसे डिजाइन करते हैं. So that is procedure. And now we are going to see the considerations. What are the factors that are to be considered in machine design? So we'll go one by one. Type of load and stresses caused by the load. The load on a machine component may act in several ways due to which the internal stresses are set up. Now we have to identify what is the type of load that is acting on the material or the component, whether it is a steady load or variable load, because if it is a steady load, then the design will be based on the permissible tensile or shear stress. If it is a variable load, then endurance limit will come in the picture. So depending on which type of load is acting on the component, we can design the component, because the stresses setup, internal stresses setup will depend on the type of load. So this is the first thing that we have to consider when we are designing a product. Then another part, no, this is motion of the parts or kinematics of motion. So if the motion selected or the kinematics or selected for the particular product is not correct, if it is not correct, then we may not get the required motion with required efficiency. So it is very much important, as I have told you here, you can see, select the possible mechanisms. Okay, so there may be three mechanisms possible, out of which if you select the third mechanism, the mechanism which is the least possible mechanism, which that if you select that mechanism, then what will happen? It will not give us the good result. If you select the first mechanism, first possible mechanism, that you may, then you may get a good result. So what this point suggests is the successful operation of any machine depends largely upon the simplest arrangement of part, which will give the required motion. So the arrangement of parts should be simple and the mechanism should be properly selected. Then next is selection of material. So once we know the stresses, once we know the load acting, we can select the various material. Again, I told you in the earlier lecture that a particular purpose can be solved by 2, 3, 4 materials. Depends on what materials are available. We will select that material. Again, the cost factor is also involved in it. So depending, again, the working condition is also a deciding factor in selection of material. So based on all these factors, the material has to be selected. Suppose you are selecting material for aircraft, then the material has to be light in weight, as well as it has to be strong enough. So you have to select a material which is light in weight and it has to be strong enough. But if you are selecting a material for a part, say for example inverter, then inverter should be bulky. So the material should be such that it should sustain or withstand enough load. So depending on for which part you are using, you have to select a material. Then form and size of the part. The form and size are based on judgment. The smallest practical cross section may be used, but it may be checked for stresses. See, what does this point says? This point says that the smallest practicable cross section may be used. For example, if you are using a bolt of say diameter 10 mm, that is M10, you are using a bolt of diameter 10 mm. It is quite possible that if you use a bolt of diameter 8 mm, then also it may not fail in stress. It may not fail. A bolt of 8 mm may not fail, because by a calculation you are getting that you should use a bolt of diameter 10 mm, but a bolt of diameter 8 mm may also not fail in the service. So you have to use judgment here. Form and size of the parts are based on judgment. You can use a 8 mm diameter bolt also, but then you have to check for the stresses. What are the values of stresses that we are getting? So this point will be more clear when we will solve few numericals. Maybe in next lecture we will solve numericals. That time you can remind me of this point. This can be clear because the smallest practical cross section may be used. Even though by calculation if you are getting 10 mm, but still 8 mm may also withstand the solve the purpose. Okay, so it should be based on the judgment. You should be able to take the decision that whether to use a 10 mm bolt or a 8 mm bolt. Then frictional resistance and lubrication. There is always a loss of power due to frictional resistance, and it should be noted that the friction is of starting is higher than the running friction. So you have to uh, give some lubrication to the parts where there is high friction. So proper oil hole should be provided so that lubrication should be given to the parts. If the part that needs lubrication is slightly inside, then the oil hole should be properly directed so that there should not be any frictional resistance, or the frictional resistance should be as minimum as possible. Then convenient and economical feature. Now this talks about the ergonomics of the product. The starting, controlling and stopping lever should be located on the basis of convenient handling. A person should not be able to reach the parts. He should the lever starting, stopping. Yesterday also I told you that the starting and stopping lever should be within the reach of the operator. It should not that he is operating at one place and the levers are placed at some different locations where he will have to get up, switch on and off the machine and then come back to his sitting position. That should not happen. So it should be located within the vicinity of the operator. This is about the convenient features. Then to replace or change part, easy access should be provided and the necessity of removing other parts to accomplish this should be avoided. I told you in the start of earlier lecture that if you want to remove a particular nut, it should not happen that you are removing the entire assembly. So the parts should be located such that the assembled such that it should be convenient to do the maintenance of that particular part. So this is convenient and economical features. Then next is use of standard part. So I have already told you about standard part. For example, if you are using shaft, then the shaft is not available in any dimension. Say if you want 16 mm, 16.5 mm, 16.7 mm shaft, it will not be available. In that case, what you will do? You will have to modify the design slightly, because every time what will happen? Every time you will have to, for example, if you need a shaft of diameter 16.6 mm, for example, if you need a shaft of diameter 16.6 mm and shaft of diameter 16.6 mm is not available, then what you can do? You can purchase the shaft of diameter 17 mm, and every time you will have to reduce 4 mm. Every time you have to reduce 4 mm. For all the parts that will be made, you will have to reduce 4 mm. So that may not be a good idea. What can be the another solution? Another solution can be use a shaft of diameter 17 mm only. Instead of using a shaft of diameter 16.6 mm, use a shaft of diameter 17 mm. Now what will happen because of this? This will increase the cost of the product. But then you have to take decision whether the machining cost for removing the 4 mm is less than the cost of the cost of 4 mm, that particular 4 mm. There you have to take decision. Based on that decision, you will either use 16.6 mm diameter shaft or you will use 17 mm diameter shaft. Again, I told you about the size of the bolt, size of the nut. It should be standard. Same size shaft, same size bolt and nut should be used. Again, if you want to use bearing, then the bearings are available in standard numbers only. So you cannot use any bearing. That also you have to take care when you are manufacturing the shaft or selecting the size of the shaft. Because the standard parts are easily available in the market and that can be fitted as it is. But if you design a product in such a way that everywhere you are putting some or other tolerance, then it will be difficult for manufacturing as well as for maintenance purpose also. Maintenance purpose also. So as far as possible, you should use standard parts. Then safety of operation. this also we have covered. Any moving part of the machine which is within the zone of the operator should be covered, so that there should not be any injury to the operator who is operating the machine, and there it will reduce the accident. It will reduce the chances of any accident. So safety of the operator should be seen first whenever a product is to be designed. The next is workshop facility. Uh, I have talked on this as well. A design engineer should be familiar with the limitation of the employer's workshop. For example, you want to perform an operation on, say, CNC machine. Okay, and um, the CNC machine is not available in the manufacturer's workshop. Then what are the alternatives? The alternatives are he can purchase the CNC machine, or he can give it to someone to perform that particular operation. Then which one will be costly? Which one will be costly? If this is costly, then this should be done. Or if this is costly, then this should be done. Or is there any other way? Is there any other way that the operation cannot be done on CNC machine or any other conventional machine which is available in the manufacturer's workshop? That has to be thought of by the design engineer. मतलब डिजाइन इंजीनियर को इतना भी सोचना पड़ेगा कि वो वर्कशॉप में वो फैसिलिटी है कि नहीं है. What, why this has to be thought of? Because what is this ultimately going to lead to? It is ultimately going to lead to the increase in cost of the product. It is going to increase the cost of the product. So again, you cannot manufacture a product at any cost. It has to be compatible to the other available products in the market. Okay, if something is available for 10 rupees and if you are selling it for 50 or 100 rupees, 50 or 100 rupees, no one will purchase it. And why are you selling it at 50 or 100 rupees? Because the cost of production is more. Why your cost of production is more? Because these things were not taken care of when the product was designed. Okay, so the workshop facility of the manufacturer has to be thought of. What are the machines available? What is the capacity? What is the limitation? Uh, in that sense, can the design be altered? Can the design be modified? That has to be taken care of by the design engineer. So it is again a consideration when a part is to be designed. For example, if it is suggested that this particular operation is to be done, say for example, tapping operation is to be done, but there is no provision for performing tapping operation in the workshop, in the particular workshop where the product is manufactured. Then in that case, what will happen? That product has to be given to someone else where tapping will be done, and then it will come back to his own workshop. That what will happen because of this? Because of this, number one, the cost of the product will increase. Number two, the time required for manufacturing will also increase. So is there any other way, instead of threads, is there any other way by which the part can be designed so that this this thing can be avoided, to give it to some other person's workshop? Can it be avoided? So this has to be taken into consideration by the designer. For that purpose, he should be familiar with what is the capability of the workshop in which the part will be manufactured. Then the number of machines to be manufactured. For example, if the articles or product is to be manufactured in lot, then in that case a new machine can be purchased. Suppose there are lakhs of pieces of a particular product to be manufactured, then in that case a new machine can be procured which is required for that purpose. Otherwise, if the number of products to be manufactured are only in 1,000, then it may be feasible to order it, outsource it, get it. If the number of parts to be manufactured are more, if it is mass production, and if it is mass production of say 10,000, 15,000 parts per day, then then some specialized machine can be used. Specialized machines can be used. For example, if you talk about gears to be manufactured, then you can use a gear hobbing machine. Instead of manufacturing it on milling machine or shaping machine or maybe casting process, you can think of getting a hobbing machine. Okay, because in hobbing machine you can it is specialized machine for manufacturing gears only. and at a time 3 to 4 gears, depending on how much is the axis for mounting the blank is given, we can manufacture more than one gear. Okay, so depending on number of parts to be manufactured, machines here means parts to be manufactured, the design may change. Okay, so this is another factor that has to be kept into mind, the number of machines or product to be manufactured before finalizing the design. Then cost of construction. The cost of construction of an article is the most important consideration involved in design. No one will purchase a product which is costly. Everyone would like to have a product which is of less cost. So as far as possible, the cost of product should be minimum, because after the cost of product, actual cost of production of a product is determined. The on that overheads are to be added, then profit is to be added, and all other things that has to be added, which will increase the cost of the product. So if the initial manufacturing cost of the product is high, then what will happen? The selling price will be much more higher. So this has to be kept into mind. Always the cost of production, cost of construction, matlab the manufacturing cost of the product should be as less as possible. तो डिजाइन इंजीनियर को ये भी देखना है कि कैसे प्रोडक्ट का कॉस्ट मैं कम कर सकता हूँ, कितना कम कर सकता हूँ. So how we can reduce the cost? One way I have told you is by use of standard parts. Second is by use of by knowing the limitations of the or capability of the workshop. Third is by changing the design, by changing the mechanism, by selecting the material which is less costly, by selecting the material which is easily available. अगर बहुत दूर से बुलाना है मटेरियल, तो उसका कॉस्ट भी ज़्यादा लगेगा, बुलाने का कॉस्ट लगेगा. And all these things has to be taken into consideration, which will reduce the cost of the or minimize the cost of the product. Then assembling. Every machine or structure must be assembled as a unit before it can function. Large unit must often be assembled in the shop, tested, and then transported to the place of service. So every machine or structure must be assembled as a unit before it can be function. For example, consider this punching machine. Okay, this is a small part. So each and every part will be assembled and will be checked. It will be checked. You can see the clearance. Is the clearance sufficient enough? Is this punch? This is a punch. Is this punch properly going through this die and cutting the paper? That will be checked. That will be checked. Now it can be 100% inspection, or it can be sampling inspection, that we are not discussing here, but the part should be checked. Either the batch should be checked or each and every product should be checked. But then see, if there is no sufficient clearance here, what will happen? This punch will not go inside this and it will not be able to perform the operation. Okay, if this space where the page is kept, if this space is small enough, if you want to insert a 100 GSM page in it, 100 GSM grams per square meter, 100 GSM का पेज उसमें डालना है, उसको पंच करना है, और ये स्पेस जो है वो 70 GSM के लिए ही है. So then that 100 GSM will not go in this, it will not fit in this. So all these things has to be checked, whether checked while assembling the product. And this product, like this small products, are assembled at a factory only, and then they are shipped as a unit. But if there are large units, suppose कोई pressure vessel है या फिर कोई ship है, then it cannot be assembled uh, at one place. सपोज शिप है तो उसका यूनिट्स अलग अलग जगह पे मैन्युफैक्चरिंग होगा, एंड देन इट विल कम एट वन प्लेस. अलग अलग जगह का मतलब होता है मे बी डिफरेंट यूनिट्स ऑफ द सेम फैक्ट्री, डिफरेंट लोकेशन ऑफ द सेम फैक्ट्री, इट विल कम एट वन प्लेस एंड देन ओनली इट विल बी इंस्पेक्टेड. और फिर या फिर प्रेशर वेसल है तो वो प्रेशर वेसल जहाँ पे इंस्टॉल करना है वहीं पे जाके वो असेंबल होगा. या उससे उससे क्या होगा, इट विल सेव द ट्रांसपोर्टेशन कॉस्ट, because to transport a bulky product it needs more cost. The cost of transportation of a bulky product is more, whereas if it is transported in pieces and then assembled at the location, its cost, transportation cost may reduce. So again, this is to be this depends on the decision has to that the engineer has to take, the particular engineer has to take, whether it should be assembled in the shop or it should be assembled at a particular location. So these are the various things called as general considerations in machine design. So you can see that general considerations, then general procedure, and this basic requirement of the design are same, and it's all similar. It's all similar. So basic design requirement and the general considerations are almost similar. So what does this consideration means? ये फैक्टर्स कंसिडर करना है हमको, इन सब के बारे में सोचना है जब भी हम पार्ट का डिजाइन करते हैं तभी.